Hello, guys. Welcome to Ramta Solutions. Welcome to your mathematics lesson on the nature of roots. So, this video will be a full guide of the nature of roots, meaning when you are done watching it, you should be competent in determining your nature of roots. And of course, you can see there are writings which have a very low transparency. At the end of this video, you should be able to determine or to use all of them. Okay, you see all these writings on the background with a low transparency. You will be using it in this video and you will be able to know them and master them. So let's not waste time and show you what we are doing. Now, you guys know that we have a quadratic formula, which is a very powerful tool that we use to solve for x, that is to determine the values of our roots, isn't it? Now, this is your quadratic formula. You remember it, right? If you don't, it's okay. In your examinations, it will be provided. In your mathematics examinations, it will be provided in the data sheet. Okay. Now, not only does this formula give you the values of the roots of your equation, it can also tell you the nature of those roots. And to find that, we have this part under the square root. Remember, the b squared minus 4ac. We are now going to give it a name. Its name will be a discriminant. Otherwise, you can call it using a symbol delta. Okay, otherwise you can call it using a symbol delta. Okay, so let me just write this delta for you so you can see it. So this delta is b squared minus 4ac. It will tell you what the nature of your roots are. Okay, all right. Now, this discriminant, remember what I said to you? I said it'll tell you the kind of roots that you have or the nature of the roots that you have. Our roots are, they can be non-real or they can be real. And if they are real, they can be equal or unequal. And if they are unequal, they can be rational or irrational. Okay, remember? So if they are real, they can either be, let me change this color. Let me change it. I think this yellow will do. If they are real, they can be what? If they are real, they can be equal or unequal. All right? They can be equal or unequal. Okay? And if they are unequal, they either irrational or rational or irrational. Okay? So if your roots are real, you must then decide whether they are equal or not equal. If they are not equal, you must also decide whether they are rational or irrational. This you will see with examples that we are going to have at the end of this video. So remember what I promised you. After this video, you will master this. Okay, now let's go to the next page. Now, remember we called this the discriminant. What was it? If you recall, it was b squared minus 4ac. Okay, so if your discriminant is less than 0, I repeat, if your discriminant is less than 0, that means if it is negative, okay, if it is negative, okay, if your discriminant is negative, you have unreal roots. Unreal or non-real, it doesn't matter, it's the same thing. Okay, if your discriminant is 0, you have non-real roots. If it is 0 or greater than 0, your roots are real. Okay, your roots are real. Okay, remember here it is positive or equal to 0. Okay, now if they are equal to 0, meaning if your, sorry, not they are, if it is, if your discriminant is equal to 0, meaning this part here, if it is equal to 0, your roots are equal. You are going to see this shortly diagrammatically or graphically what they represent. Okay, if they are, if your discriminant is equal to 0, you say your roots are equal. Okay, now if it is greater than 0, meaning if your discriminant is positive, here we are referring to positive. Okay, if your discriminant is positive, your roots are unequal. Okay, your roots are unequal. Okay, we have sorted that out. Remember, if your roots are, rather, if your discriminant is less than 0, your roots are non-real, you leave it there. Now, if it is equal to 0 or greater than 0, you say your roots are real. Then you then determine, is it equal to 0 or greater than 0? If it is equal to 0, you say they are equal. And then if it is greater than 0, you say they are unequal. Now that you have said they are unequal, let's see this. If they are, this is what we call a perfect square. If your discriminant, is a perfect square, okay, a perfect square is your 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on, meaning your 1, 4, 19, 16, 25, 36, 49, 64, and so on. Okay, that's your perfect square. 1 square, 2 square, 3 square, and so on. If they are like that, okay, then your roots are rational. Okay, if they are equal to a perfect square, they are rational. Okay, now if your roots are not equal to a perfect square, they are irrational. Remember, guys, a rational number can be written as a fraction in the form a over b, and irrational cannot be written in the form a over b. So this is now a revision of your grade 10 number systems, right? Now, this is what we have, okay? This is what we have. Proceeding. Now, I said to you, we can represent this information that we had graphically. You remember? I said we can represent this information that we had graphically, right? So I'm not coming back to this page again, guys. Okay, I'm not coming back to it. Because you are watching on a video and you are also writing down, I know it off by heart. So if you are writing this down, note it down. When we come back later, or when we are solving these questions later, I'm not going to be coming back to the page. So please note it down. If you're watching on YouTube, of course, you are pausing the video and to note this thing down. Okay? Perfect. Now, let's see. We said we can represent those things graphically. Now, check this out. Do you see this? Now, these, do you know what your x-intercepts are? You do not know them, or they do not exist. When they do not exist, you say the roots are unreal. So this graph represent unreal roots. Okay? This graph represent unreal or non-real roots. Okay? Perfect. Let's look at this one. You know, this is a parabola or a quadratic graph. The highest power of that equation is 2. That says to you, at most, you will have 2 roots. But now, you only have 1 root here. What we also say is that the roots are repeating. If they are repeating, the first root is 1, is 2, and the second root is also 2. What does it mean? Oh, the first one was 2, and the second one is 2. It means they are equal. So this is a graph that represents equal roots. Can you see that? So for equal roots, the x-intercept is also the axis of symmetry, or the x value of the turning point. Do you guys see this? I repeat, the x-intercept of the graph is also the axis of symmetry, or the x value of the turning point of the graph. Okay, perfect. Now let's look at these ones. -3, the roots are -3 and 1. This can be written as a fraction, of course. So these values, they are rational values, all right? They are rational values. So the roots here are rational, okay? The roots here are rational, right? Now let's look at these ones. Obviously, square root of 6, square root of 3, these are irrational numbers. So obviously, since they are irrational numbers, we don't waste time. The roots are irrational. So remember all these, oops. Remember all these, and all these are what? Are real roots, right? All these are real roots, right? All these are real roots. And this is your unreal root, right? Perfect. Proceeding. Right now, we're going to start with um, examples. Now, let's see with our examples, determine the nature of roots for this equation. So let's see, x squared minus 4x minus 7 equal, x squared minus 4x equals negative 7. So let's see, this is x squared minus 4x equals negative 7. You must write it in the form ax squared plus bx plus c equals 0. So it will be x squared minus 4x plus 7 equals 0. So obviously, when you look at this, a is 1. What is b? B is negative 4. What is c? C is positive 7, right? C is positive 7. Let me confirm. Yes, it's correct. Okay, so remember now we will say b squared minus 4ac. What is it? That is your discriminant. Even if you write delta equals b squared minus 4ac, it doesn't matter, guys. Okay, so what is the value of b? The value of b is negative 4 square, close bracket. Do you see this? Let me do this. Do you see what I have done here, guys? I put it in a bracket. Negative 4 close square minus 4. What is the value of a? A, its coefficient, you can see it's the coefficient of x squared. It's 1. What is the value of c? It's positive 7. So what is this? You guys have calculators. This is 16 plus 28. 16 plus 28. No, not 16 plus 28, but 16 minus 28 will be negative 12. Negative 12, the discriminant is less than 0. Therefore, the roots are non-real. Okay, the roots are non-real. We don't even have to go anywhere else. We leave it here. Okay, now let's remind ourselves what the second one was. Let's go back. X squared plus x minus 12. X squared plus x minus 12 equals 0. Let's remind ourselves a is 1. Remember, it comes in the form ax squared plus bx plus c equals 0. A equals 1. What is b? B is the coefficient of x. It is equal to 1. What is c? C is the constant. It is equal to negative 12. Okay. So, for those that maybe didn't understand what I meant when I said you don't have to write the discriminant, I meant you don't have to do this. You can just say b squared minus 4ac, just like I did here. Okay. What is the value of b? It is 1. What is the value of a? Again, it is 1. What is the value of c? It is negative 12. Now, what is this? This is 1 plus 48, isn't it? This is 1 plus 48. So this is 49. So you must ask yourself 49. So therefore, what do you say about the roots? Therefore, the roots are they less than 0? No. So they are real. Are they equal to 0? No. So they are unequal. Is 49 a perfect square? In order for you to know if something is a perfect square, you just put whatever you have under a square root. Obviously, 49 is a perfect square. It is 7 squared, so it means it is rational, right? And rational, okay? And rational. The roots are real, unequal, and rational. Indeed, these roots will be unequal, and I'm going to show you. I'm gonna show you. I'm changing the color. Let me use a blue maybe. Check this out. If you factorize this, it'll be zero. It'll be x minus, leave a space, close, x minus, leave a space, close, equals 0. Factors of 12 are 112. Products right of the factors of 12 are 112, 2, 6, 3, 4. I will work with 3, 4. But the constant is negative. It means the bigger must be must take the sign of the middle term, which is positive. So the bigger one must be positive. Indeed, x equals 3 or x equals negative 4. Do you see this? These are unequal roots and they are rational. Do you see this? And this is how you determine the nature of roots. Okay, guys? I hope you guys are happy. All right, perfect. Moving on. Let's see what else we have. So I hope you guys now understand. Remember, you go to that diagram that we had. You first look at, is the discriminant negative? If it's not negative, it means the roots are real. Okay, if they are real, are they greater than 0 or less than 0? In this case, they were greater than 0. It means they are unequal. Oh, okay. And is this rational or irrational? Remember I said to you, to test whether they are rational, you have your answer there. Just put your answer in a square root. If you find, let's say, a whole number, you must know that your roots are rational. But if you find it with something else, with decimals, it is not. They are not rational. Okay, they are not rational. But if you also want to know, you also need to know your squares: 1 square, 2 square, 3 squares, and so on. If you know them, you are good to go. Okay, if your answer is like that, is a perfect square, you must know that your roots are rational. If not, they are irrational. Okay, perfect. Now, let's look at this. It's a second example. We're gonna have about 3 examples. The first being the one we just did. This is the second. So let's see. The root of a quadratic equation I given, I given by x equals -2 plus minus the square root of 4 minus 20k all over 2. Determine the value or values of k for which the equation will have real roots. So the discriminant here is whatever that's under the square root. So here I'm telling you the discriminant is basically b squared minus 4ac. Guys, this you know, right? But in this case, it is what? Our discriminant is whatever that's under the square root is 4 minus 20k. Now highlight this. They say for which the equation will have real roots. For it to have real roots, it means the discriminant must be greater or equal to 0. Isn't it? Must be greater or equal to 0. Right? Let's go now. What are we saying? We are saying 4 minus 20k is greater or equal to 0. Right? Now, minus 20k is greater or equal to -4. The 4 dividing throughout by -20 will be k is less or equal to 1 over 5. Let's see. That's it. Okay, that's it. Ooh, my mistake. Sorry about this. I see my mistake. Oh no, I'm right. It's 4 minus, yeah. It's 4 minus 20k. I didn't make a mistake. It's 4 minus 20k, so we are good. Let me see. 4 minus 20k, we are good. All right. So any k value that is less than 1 over 5 will give you real roots. If you have k greater than 1 over 5, you will not have that. I think I should give you an example here. But no, I don't have to give you an example. Let me just explain. Think of any number that is less than 1 over 5. I can even think of 0. Right? I can even think of 0. If you substitute whether's k, whether's k, you put 0, you're gonna get real roots. Right? You're gonna get real roots. And if you substitute greater than 1 over 5, let's say 1, you're gonna get unreal roots. And that's not what you're supposed to be doing. So we are content. This answer is correct. I know there are some that are looking at this and they're like, wow, I repeat. They said the roots of this quadratic equation are given by this equation here. Now we need to determine the value or values of k for which the equation will have real roots. By saying real roots, we know by default it means the discriminant must be greater or equal to 0, right? They must have the value of the discriminant must be greater or equal to 0. The discriminant is whatever that is under the square root. Okay, so we just substitute that like we did here. Okay, and we solve for k. And this is something that you know. Okay, as simple as that. Okay, perfect. Now let's try another one. For which values of m will the equation this, let me see, okay? For which values of m, for which value or values of m will the equation 2x 2x times x plus 1 close plus m equals x have non-real roots? So first thing first, we need to begin with 2x multiplied by or open bracket x plus 1 close plus m is equal to x. Let's proceed. This will be simplifying. 2x times x will be 2x squared. 2x plus, 2x times positive 1 will be plus 2x plus m minus x equals 0, isn't it? So check what you have here. Further simplification, 2x squared plus 2, not 2x, but rather x, isn't it? Not 2x, but x. Right, not 2x, but x, because 2x minus x plus m is greater than 0. Do you see this? Now you have it in the form ax squared plus bx plus c. So what do we say? A equals 2, b equals 1, c equals m. Let's go back to confirm. Indeed, a equals 2, b equals x, and m equals, c equals m, because c is the constant, right? So remember, they said this non-real. For them to be non-real, it means the discriminant must be less than 0. Okay, so what do we say? We say b squared minus 4ac must be less than 0. Guys, even if you had written maybe delta is less than 0 and proceeded by saying this, there was nothing wrong. What is b? B is 1. What is a? A is 2. What is m? Sorry, what is c? C is m, and these are greater than 0. So 1 squared is 1. 4 times 2 is 8, times m is minus 8m, and this is less than 0. Okay, so what do we have? We have negative 8m is less than negative 1. Dividing throughout by negative, we get m is greater than 1 over 8. So these are the nature of roots. For this equation to have non-real roots, m must be greater than 1 over 8. And this is how you are going to solve questions of the nature of roots. So we have come to the end of our lesson, and I want to say to you guys, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za, or since you are watching on YouTube, that in the description of this video you will find the link to all these social media platforms. Okay, you will find a link to all these social media platforms. And again, because you are watching on YouTube, please like, subscribe, and share with your friends and classmates, right? And remember, we care for your studies. All the best, and bye bye.